Hi, I'm Stefan, and I'm the host and organizer of the emBO++, the next level conference for embedded software developers. The talk you're about to watch is about how to not choke on a big old project. It was given by Yuri Minaev at the emBO++ 2021, and thanks to Leica Geosystems, you can see this video for free.
Okay, so we see the big screen, right? Okay. Mm-hmm. Okay. I'll just reset my timer here and all right. All right. Before we begin, I hope everyone can hear me just fine. And um, if during the talk you have any questions, please put them in the chat. I'm looking at it right here on my other monitor, and I think I will answer them just as they appear, the questions, and we shall not wait for the end. Well, if they are not uh, too long to answer anyway. So we've got like about a couple of minutes before we begin, and then we'll start. Okay, I think we can begin now. All right. Um, so today I'm going to tell you about old projects, the pain related to them, and legacy code, and all that good stuff. So a little bit about me. My name is Yuri. I work at PVS Studio. If you don't know, it's a company which makes a static code analyzer for several languages. I'm working on the C++ part specifically. And what a static analyzer is, well, we'll look at it today a little bit. But basically, it's a tool which looks at your source code and finds errors, typos, and stuff like that. It also uses some advanced things like data flow analysis, but it's not. Let's not delve too deep into it right now. So what I was going to tell you about today is that the world we live in is changing rapidly in terms of how many lines of code we already have, and the size of projects becomes bigger and bigger. It's kind of a subtle change, which goes unnoticed, but we are far into software development in terms of timeline, so they grow. So what happened? Well, if you have a project, oh my goodness, I hear someone. Okay, so what happened? If you've got a project which uh, which has a history, you might see something like that there. Um, I know this from experience because our project is a big one. It's an old one, and any old enough project grows a lot of hair. It has bugs. It has old code. It has new code, and this all is written, of course, by different people on teams, and code goes like every new layer of code adds something interesting into that equation. It goes kind of undetected because who cares, right? You write a new feature, it works great, wonderful. And at this point, well, yeah, Captain, obvious, right? Um, what do you want to tell us, right? Uh, well, I'm going to tell you a little bit of statistics. So maybe from this quote by Mark Twain, you might think I'm going to lie to you. Well, maybe not. We'll see. I promise I won't lie. Okay, so statistics. Let's take a look at some projects with history. It's Linux. Linux has come a long way, and uh, at, in the red at the right there, you see the lines of code in the Linux kernel. Uh, the top part is when it appeared, and the bottom part is, well, it's 2017. I'm not sure how many lines it has now, but it's a huge thing, basically. Photoshop. Well, yeah, Photoshop has grown considerably. And if you know what this is, well, this is that. And it also has a ton of code in it, which sometimes it shows kind of. Okay, so what? So what's the point, right? You look at a project, you see this, uh, you see it, how geology basically works in action. It becomes unmaintainable at some point in terms of errors, because um, if you don't pay attention to what's going on in your code, it will get bloated and it will die. And more importantly, every project has a lot of outdated code written, 5, 10 years ago. And this is known as legacy. Let's take a look at what legacy is. Well, it's something inherited from another version, an older version of software, or another person. This is a Wikipedia definition, and I find it really boring because, yeah, what does it tell us? I'll talk now about my personal experience in this area, and from my experience, it's more like this usually. Up close, you go into it, you see, well, scary things, a lot of them, and you want to do something about it. From afar, if you don't go too close, it might look kind of pretty. It's a monolith, solid thing which works. It's great. It's wonderful. But let's look inside that monolith. I'm talking from my experience again because this is based on our project and it causes a lot of pain. Well, at least it used to. Now we are currently working on improving it in terms of, removing legacy and rewriting things. Okay, so what do we have there? Well, we have some foundation, right? Someone wrote some foundation in like 1995 when the project was starting. It's old code. It has assembly um, blocks and stuff like that, and you just cannot understand what it is basically usually if you look at it unprepared. Okay, we've got third-party libraries. Of course we do, right? Because who wants to write things from scratch? We use libraries. Well, at some point, it becomes difficult to, keep this thing from falling. So you add crutches, you add supports. There's a lot of them. Sometimes it means that there's just no time for proper solution. There's something of a core module, usually, which, it was written because we had to have it right now. It's not architectured very well. It may leak abstractions. Our core module used to leak abstractions real bad. And we've got this wonderful place, because why not? Because even though we use libraries, we like to invent things. C++ programmers love to write things from scratch. Oh, I see in the chat that Linux was last time 21 million lines of code. Yeah, that's that's great. Um, okay, so we reinvent wheels constantly, and there are dirty fixes. I know I wrote a number of those myself. I'm kind of ashamed. And at the top here, we've got that glorious modern, code, which is great and fine and wonderful. And it's like, if you look at the percentage, usually it's not too much of it. Okay. So now that we've took a look at this monolith, let's see what happens when you try to find a bug there. It happens, I know. So you're looking for this little thing. It's cute. It doesn't look scary at first because, well, it's some bug which happens. It doesn't crash anything. Just something is working not as you would expect it to. Okay, so what shall we do? How are we going to catch that insect? Well, of course, we go and debug our code. We get into the source, we put a breakpoint, we go step by step, and at some point we go deeper and deeper and deeper and deeper into the old part of the software. And at some point we pick up the code, and what we see, well, we see something like that. A ton of spaghetti. Unfortunately, I can't show you, codes from some part of PVS Studio, which shall not be named. But if I could show it to you, you would probably see what I mean. Okay, yeah, that's great. That's really tasty. A tasty lunch that we have there. What it means in the real world is that you probably end up debugging for a long time. And as time passes, you get tired, you're trying to find that thing. By the way, when you actually find that thing after a couple of hours working with your debugger, usually it will be like 2 lines of edits. And yeah, you go into the eye of terror, and your really nice, pretty bug, which we saw earlier, it kind of looks like that. Sometimes it's even impossible to fix some bugs easily, and you have to add a new support or a new crutch, which is ugly. Also, in a nutshell, as your project grows, debugging gets longer and it gets harder, especially if you touch old areas. It's specifically, it is hard because there are those crutches, supports, and small architectural solutions, as we like to call them, which are sometimes not obvious. And it is good if there is a comment there telling you the reason for a specific thing, but in many cases there's no comment, so you end up having to figure it out yourself. You are forced in many cases to add those dirty fixes, because right now it's too tedious, or it will be too much too much code to edit. So you just plug the hole and you move on. Well, at least on the upside, that's kind of comforting. You feel like you are really that cool tech priest. By the way, here I'm going to digress here a little bit. Um, I found this quote at some point on the internet, and I loved it because it shows the problem I'm talking about really good. Basically, what it says is uh, code is your kind of an enemy of yours. Uh, of course, we have to write code. Of course, we cannot avoid writing code because all software development is about writing code, but uh, you should have a good reason for adding something, be it a feature or a fix or anything else. Um, if you can solve a problem by removing code, I think it's better to do that than to add more. So writing a new line is not something you just do because you want to. And at this point, I'll tell you a story of my life. Well, from my life, not of my life. I used to work on one uh, international company which was well known in some circles. I won't tell you which company it was, but it doesn't really matter. I'm talking about legacy. So they had this awesome product which lasted for years. And of course, a product should live. And what it means is that it should get new features. So this is how it works. You all know that. You take a product, you add a feature, and hopefully at the end you get a better product. So it's good. But their thing, they were developing this one. It had a lot of questionable architectural decisions. It wasn't tested. No one, well, it was tested, but not thoroughly enough. And nobody thought about adding, about future. So nobody thought what would happen in like 10 years time when we need to add support for technology which is not known yet. So at some point, one thing happened, and one feature, one specific feature which was important, it got stubborn as a cat. And trust me, I've got two of those. Well, cats not features, and they are stubborn really. So it refused to get into the project, and they didn't know how to make a better product because of that. So it was basically a war, trying to fit this stubborn thing in the box. The war was, well, it was bloody. Let's say it like that. And what they ended up doing, they made a tough decision to, scratch it. We don't want to fight with this thing anymore, so they rewrote the entire thing from scratch, and they ended up losing several developers because 4 months of constant overtime work doesn't work well for human psyche usually. So some people just resigned. Or they left the company after that. It ended well. The product is alive today. It's working. I think and I hope they learned from their experience, but this is what happens sometimes. So, okay, I'm scaring you. Maybe, maybe I'm not. Maybe you're not so scared as I'm thinking right now. But okay, it's to me it was a scary thing to observe. So, what can we do to don't let that happen? Well, in the perfect world, of course, we just don't let it happen. We just write perfect code. We just create a great architecture. The structure of our project is that we can add things easily, we can fix these things easily, but unfortunately it doesn't work. So we have to refactor old parts uh, it um, before it's too late to do some edits. It's a slow process, but unfortunately we have to do that, especially as your project develops. Um, if possible, automation is very important. If you can make a machine work, make the machine work. Don't do yourself something that you can make a robot do. Also, we need a good tool set to make it all possible. A tool set, what I mean by that is not just your compiler, but tools you can use in your development cycle besides your compiler. And by the way, are you using tests in your project? I hope you are, and I hope it's not um, this, because I've seen a thing like that when there were tests formally. Uh, they were tests. Well, the code base was covered, but the tests were written badly and they didn't really do anything useful. Okay, so the first thing I think we should do in a big project is, if you're lacking test coverage in some areas, do it as soon as possible. It will help you. From my experience, new tests helped catch bugs which were stubborn and uncatchable before. If unsure, you just add more, because you know if you think about adding or not adding tests, it's better to add it. And of course, you need a CI system, because manually managing everything is a pain. It should work automatically. Now let's take a look at this thing called DevOps. I'll assume we have a CI and we have that DevOps cycle everyone knows about, and it's kind of today it's a hot topic. Everyone loves it. It's all good, but it's not enough. Tests are fine and great, but they are not enough. We need to add another piece of a puzzle in this scheme, and that is monitoring on every step of the life cycle in the CI automatically. You need to you need to monitor your code constantly to find errors and bugs at the earliest stage possible. Uh, why? Why do we have to monitor it? Because we have code reviews. We don't really have to run anything besides a compiler, which will warn us of um, potential problems in our code. Well, yeah, good on you, good on us all. We have code reviews. I'll just show you in a moment what code reviews in the real world may look like and what's left after them. So let's review some code. Right? Imagine someone calls you and says, "Hey, let's do a quick review." I, we do it in person usually. You can do it in in pull requests and stuff like that. It's not really important. So imagine it's like 4 p.m. You want to go home and someone comes up to you and says, "Okay, let's go review my code I wrote recently." And you go to them and you look through the code. Like some time passes. You get tired. You want to go home, and you see an if statement like that. Well, I don't know about you, but my brain here says, um, "Okay, I don't want to see it. Um, that's fine. Let's move on." So by the way, can anyone spot an error? Well, usually I would pause here and ask you to, to talk to me. Oh, yeah, great. Somebody spotted errors. Right, you're right. So this thing is checked twice. This is code from a real project. Um, it's a game engine. Copy paste, right? So it's a game engine. Some gamepad input is probably, well, probably is processed here. So they ended up copy pasting the same thing, and they forgot to edit the copy paste line. And this happens all the time, and people overlook this all the time. So uh, this is how you can miss a bug on code review, and it might not be critical or really a huge deal, but sometimes it may be a huge deal, and it may even fire in a year uh, in some specific case. Those are the nastiest, the dormant bugs which bite you after some time. Okay, let's take a look at a different example. It's shorter, it's easier. There's no that stupid if statement with a lot of checks. Right, so what do you think that is? All right, I'll just wait like a couple of seconds and I'll tell you. Yeah, it's a missing semicolon. So what this code says, it says if not um, whatever the variable name is there, we just return the result of the clear method of a vector, which last I checked, clear doesn't really return anything. And as you can see here, we have void. So are we seriously returning void from a function? I was surprised when I first saw that. Well, yeah, we are seriously returning a void from a function. Does it compile? Let's have a look. I've got a small example here, a smaller one. So does it compile? Well, turns out it does compile. So you see clan here, and it has warnings on. It has all warnings on, basically. I think W extra should be there, but it might be cut on the picture. So the clan is silent. It's happy. Everything is great. Everything compiles. We get no warnings. So it's just valid code. Um, is it valid? Yes, it's legal. If we look in the C++ standard, it explicitly says that if an expression in the return statement has the type void and the function itself is a void one, uh, you can return void from the void function. Well, yeah, it was a fun experience finding this out at some point. Okay, so back on track, monitoring. What do we have here? What do I mean? We've got compiler warnings, and usually we, in our project, we have the W error always on. We also have dynamic analysis, also known as sanitizers. We've got static analysis, which is what I'm working on as my job. And we've got code quality controls, which allow us to code quality platforms, which allow us to set up quality gates in our CI system, so that if something goes bad, if some of those previous steps complain, we can fail the build and fix things before they get further into the software lifecycle. About compilers, well, it's usually simple and easy. You just put all those good, um, flags, and you build your code. And if something is wrong, you get a compile time error. It fails, and you go fix it. It may be on if you had your project developed without all those flags and you just suddenly put them on, you might have a really unpleasant surprise because in your old code something will fail and explode with an error because there was no warning there before to begin with, and now there is. So the compiler is easy. You just set it up, you fix all the warnings it complains about, and your code becomes a tiny bit better. So what's the next step we are going to set up in our CI system, in our pipeline? Well, dynamic analysis. Um, does anyone have any experience working with a sanitizer? Well, it's about dynamic, right? Yes, I thought so. So it's about dynamic, not that, that. It's about dynamic, and it's about keeping your code clean. But unfortunately, those things work on at runtime, and they require the code with errors to actually be executed. So here's an example. I see a number of people know about sanitizers and use them. That's great. That's wonderful. So here's this stupid piece of code which I wrote specifically for that for today. And it has this thing here which returns a value from a memory area which has been already freed. So we get an output like that. Mm, and important bits are in red here. And if you're like me, you don't like to stare at walls of text. So here it is. It found our problem, which was intentionally put there. And now it complains where the compiler didn't. So great. One disadvantage of this approach is that you actually need to go well, every path in the program basically. So you need a good test coverage. That's why I started with tests. Write tests, make sure your code is well tested. And then a sanitizer, if it manages to finish its job overnight, will help you a ton, because sanitizers make everything slow. Um, this is how we catch errors at runtime. This is how I recommend doing that. Is ASUN working for embedded targets or only running on the host? I think it's running on the host. I'm not sure about the embedded targets and ASUN because we usually do all our tests at desktop machines, because on servers, because we don't really, our analyzer really doesn't work on embedded targets. But the previous talk about tests, I think you can set it up on your host and run a synthesizer there. Well, this is about dynamic analysis. Let's go to static analysis, which is what that's my area. So again, we talked about code review. So imagine it's time for code review, but if you're like me, you are lazy, boring. It's boring to do. Well, I'm joking, of course, but it's boring to do. I have no time. I'm tired. I want to go home, and a lot of excuses. And the question becomes, could anyone else do that? Well, preferably a machine. Well, turns out a machine could do your code review. It's not happy about it, but it will comply. And that is what static analysis is for. It's a low-level code review which hunts typos and maybe some things which you can easily miss as a human. I think that humans should look at a bigger picture than hunting lines of code with some tiny errors. So this is where static analyzers will help you. So our previous example, again, I will use examples of warnings, PVS Studio issues, because that's what I know best. Other analyzers, there are a number of them, can also catch those types of errors. So here, if you just ran static analysis, you would get this warning that, okay, you've got two identical expressions in the check. And the second example is also caught. There is a diagnostic rule which catches missing semicolons. And this frees a lot of time when you go reviewing if it was checked with a static analyzer and all those small things were fixed. You just look at a big picture. You just look at algorithms. You just look at design solutions and stuff like that. You don't hunt small, tiny problems. But also optimization diagnostics. So you can sometimes even optimize your code based on the recommendations of a tool. It also has a little bit of a creative use. It was what I'll tell you right now. It was a bit of a trolling, really, on our part. But let's say you have a proprietary object, and you have that really cool library you want to use. Your project is closed source, of course, since it's you just don't want to show it to anyone. And the library you want to use, well, you want to edit, but it has a problem.
Wir sind hier in einem kleineren Grossraumbüro.
Bei den Leitern habe ich die Freiheit, dass ich, wenn ich anfange und wenn ich höre mit dem Arbeiten, eigentlich selber einteilen kann.
Overall, how I will do it, it's just up to me and they give me a lot of freedom.
Für mich ist die Faszination, mit anderen Leuten einen kreativen Moment zu generieren.
Great colleagues, great environment basically.
It's really nice here and I don't have any issues living here.
Am meisten schätze ich in den Leica Geosystems, dass wir ein sehr junges Team sind, sowie dass ich auch meine Arbeitszeit in einem gewissen Raum selber bestimmen kann.
And I could merge my life hobby with my office job.
Das Besondere an der Leica Geosystem ist sicher die Kultur und die Dynamik, die es gibt in dem Team. Es ist jeden Tag ein bisschen anders.
We have good organization which will help you to get used to the company in the first couple of months especially.
Das ist sehr interessant und ja, macht mir Spaß.
The problem is it's licensed under GPL, which makes you open your own code, which uses the GPL license code. And someone just decided to add it anyway and don't tell anyone. So what happens here? Well, legally, that makes you a nasty creature which steals and other people's work and uses it illegally, especially in a commercial project. So how do you catch that? Well, you can of course look at your project and try to find out any modules which use bad licenses, quote unquote. You essentially are looking for something like that. But what we did some time ago, we added a diagnostic rule which can catch that. So I'm not sure about other static analyzers, but with PVS Studio, you can certainly catch cases when GPL license code was added to your closed source project. Oh, and questions. There's something interesting is going on in the chat. I was never convinced for the enforcement of curly braces in every code block. Well, you know, there is a rule about this in MISRA. So about curly braces, which they make you put everywhere. Okay, so I think embedded people, you know about MISRA really, really much. Yeah, okay. All right, so one drawback, a significant drawback of static code analyzer. If you have a big project which you have never used static analysis on before, you take something. It's the same really as with compiler warnings. You take some analyzer, you run it, and you see this bloat of, meaningless and pointless errors. There are thousands of them, especially if you enable something like Misra, because Misra loves to complain about things, and we had instances when we enabled Misra and checked a project which was not designed for Misra, and we had like 40,000 of warnings in that project just from Misra alone for the first time. So that's kind of scary, and that's kind of I think turns people back from using tools like that. But there is a solution. I'll just tell you about it in a moment. So what's that? What was that? What was that bloat of errors? So any old code, as I said, it's a lot of noise from a static code analyzer. Even if it's tested well, because you never know what this tool will find. You can't fix it in advance, and now it's not a problem of a tool. Every static analyzer produces noise in some form, and so what to do? Well, if you have no choice and you have an old project and you decide to use a static analysis on it, you just run it once, you suppress everything, and it becomes your technical debt. And subsequent runs you perform on newly written code. And what about technical debt? Well, you return to it and you gradually fix it. You review old warnings and stuff like that. Or you can just leave it as it is if it doesn't bother you. If you know in some places the warnings you got are false positives. And one more important thing about technical debt and those, suppressed warnings is if you're going to do refactoring, your code will be essentially new. So even if you ignored everything issued on some file, you will still get new warnings as you rewrite code. So which is better, static or dynamic? Well, both, actually. I think it's kind of obvious because they are different things and they complement each other. But just to reiterate, dynamic analysis, it's kind of a good sniper rifle. It's precise. It doesn't miss, but it's slow. If you're using a thing like that, it's gonna be slow to fight off an invasion of bugs. That's about sanitizers. Dynamic analysis, static analysis, sorry, is something like a machine gun. It's fast. It's really fast. It works. Well, usually it's faster than compilation or it's a comparable time, but it misses a lot. It can issue false positives. It can complain about something, which is perfectly fine. You just need to kind of set it up properly. Okay. And one last piece of a puzzle we need to put, we need to set up our tools which allow us to monitor our project, and we need to put them all together. And here's where quality control platforms like SonarQube come in. If you know about SonarQube, that's great. If you don't, it's a quality platform. It's web-based, and it allows you to integrate different tools in one place. And this wiki definition is of course boring. I don't like it. So it's an open source thing. It is extensible. You can set it up and integrate it in your CI system. And you can set up quality gates there. And it has charts and graphs, and it allows you to use to collect metrics on your code. This is what it looks like. We've got a gate. Oh, goodness. We've got a quality gate. You set up at which percentage of new errors, for example, it should fail, you build. And then you run it, you get something like that. All tools integrated. There are ways to add custom sanitizers, for example, and their output. It allows you to jump right to source code on which a warning is issued. Yeah, here is an output from WallGrind about a function similar to what I've shown you before with malloc and return x5. And it allows you to see the dynamics of your project and see how well it's doing. It's like measuring its temperature regularly to monitor its health. Okay, so why? Just to make it nice and simple in one place, why do we need to monitor everything? Well, because if you integrate all those tools into your pipeline, they allow you to fix the most annoying issues quickly. You can you have more control over technical debt. You can organize it. You can get rid of it more efficiently. New code will be more bugless as it would have been without a toolset, monitoring toolset in your CI. And you will have metrics, as I showed you before on the previous slide about SonarQube. It allows you to measure its temperature, basically, and its blood pressure, and make sure your project is healthy. And overall, it's more control over your code base, which is also always good. You know what's going on there. Okay, so summary. An old project may be scary, but dealing with it is doable, really. You just need to be wary of legacy and keep an eye on it, and use your other tools other than the compiler to check the project for errors. And as the more automation you have, the better. And yeah, you need to really constantly evaluate the quality of your code to make it easier for you to deal with really old project. Okay, so I think that's it. And if you have any questions, if anyone wants to ask anything, we still have time. So I'll just look at the chat for several minutes and answer everything I can. Okay, so anyway, I guess we can wrap it up. If you want to catch me, I'll be somewhere around here, probably in the lobby, because we don't have much time for to talk here. So I will be in the lobby. You can find me there. I'm a dude with a green hat, as you can see. So thank you everyone for listening. Thank you. Oh.
If you found this video informative, make sure to subscribe our channel. Click the thumbs up if you liked it, or leave us a comment on what we could improve. If you are looking for a job in the embedded industry, or you've got one to offer, drop us a mail to jobs jobs@embo.io. That's jobs@embo.io. And we'll make sure that you match up. My name is Stefan Bückelmann, and as long as you keep watching, we'll keep covering the internals of the embedded industry.